Record. Okay, perfect. So first, guys, do you have any specific question about the review sheet or the homeworks in general? I mean, if you have any specific question about the review sheet, I can start with your your question. No specific questions. All right. So I can do the review sheet. Yes.
Can you start with 1B, please, on the review sheet?
Okay. Yeah, I can do that. Sure. I can start. So yeah. So let's start with problem number 1 then, from the review sheet. So problem number 1. No, but you know, guys, because the thing is, probably we don't have time to do all the review sheets. So that's why I'm asking if you have any specific questions. So then we can do, you know, at least what you need to know, you know. So so this is from the review sheet, of course. So so you have to determine whether the equation or the graph, whether y is a function of x. So let's say, well, let's start with a first. Okay, you have x squared plus y squared equals to 5. Okay, so to determine whether y is a function of x, so whenever you have an equation, so this is an equation, of course. This is an equation, of course. So then what you have to do is you have to solve for y. Okay, you have to solve for y. Okay, and so if you solve for y, this is x squared plus y squared equals to 5. You know, let's say you subtract x squared from both sides. So then you have y squared equals to 5 minus x squared. So then, you know, apply square root both sides. Here's my square root. And then, because, just be careful, because this is, you know, even power. Because it's even power, then you're going to need a plus or minus here. All right. So then your y, it's actually plus or minus square root of 5 minus x squared. Just be careful, guys. This is a common mistake. You know, square root of 5 minus x squared, you cannot really split the expression under the square root. So this is not, I mean, this is not equal to square root of 5 minus x. That's not true. Okay, this is not, it's not true. Okay, so they're not equal. Anyway, so because you have this plus or minus, so it means you're gonna have, you know, in order to be a function, for each input x, there is exactly one output. Okay, but here, because of plus or minus, you have two possible outputs. So if you have two possible outputs, then y is not a function of x. So we have two possible outputs. We have two possible outputs because of the plus or minus. Okay, then, so then y is not a function of x. It's not a function of x. Now in B, function of x. In B, because y, the power in B is odd, it's y cubed. You know, so this is in B. Oops. Guys, again, please feel free to interrupt me and ask questions. All right. So in B, we have minus, you know, x squared minus y cubed plus 4 equals 1. This is, again, this is an equation, right? So we have to solve for y. So if you solve for y, let's say, so this is plus x squared. So that's minus y cubed plus 4 equals to 1 plus x squared. And then you subtract 4. So minus 4 minus 4. So that would be minus y cubed. 1 minus 4, it's negative 3, of course, plus x. And then, so there's a negative y cubed. So to get rid of the negative, I'm going to divide by negative 1. So here's my over negative 1. And here, the whole thing here over negative 1. Right? So then, Of course, negative over negative, that would be positive. So that would be what? That would be y cubed. Y cubed equals to negative 3 over negative 1. That's positive 3. And plus x over negative 1. That's minus x. All right. So now I can apply the third root, both sides. So here's my third root. Here's my, oh yeah, x squared. Thank you. Yeah, absolutely. Yeah, it was the square. I forgot the square. Thank you. There's a square here. Thank you. Thank you. So then you apply third root, both sides. So then your y, and here, because the power is odd, then there's no plus or minus. Okay, it's odd. 3 is odd. Okay, it's odd power. Then there is no plus or minus. So then y is just the third root of 3 minus x squared. And because there's no plus or minus, so if you pick a random value of x, for example, 0, then you're going to have like just one possible output. Like if x is 0, that will be the third root of 3, right? So it's going to be just one possible output. So we have only one possible output. So then y is a function of x. Okay, so it's 1.
Wait, what happened to the -1 that was underneath the problem?
No, that's because I divided by -1, right? Because, yeah, it's just because to get rid of the minus sign, because the minus y cubed, I divide by -1, so that's positive. So what I'm saying, this is positive here, right? So that's positive y cubed. And then, of course, here I change the sign, minus -3 over -1, that's plus 3. And the plus x squared over -1, that's this minus x squared here. So, yeah, so here we have yes, -4, yeah, but the thing is 1, you see here, there's 1 here. 1 minus 4, it's -3. I don't understand your question, Raktim. What do you mean it will be in decimal? Yeah, so what I'm saying, this is 1 minus 4, it's the -3. Yeah, so it's a function of x, yes. So we have only one possible output. So then y is function of x. Oh yeah, sure. Yeah, Rectim, you're right. Yeah. Yeah, it could be decimal, of course. Yeah, for sure. Yeah, so that's for number B. For C is kind of tricky because in C we cannot. Well, I mean, you can try to solve for y, but let's see what happens in C. So for number C, so you have y squared minus 2y minus x equals to 2. All right. So if you try to solve for y, well, you can, for example, add plus x here, both sides, plus x. So then y squared minus 2y, all right, equals to 2 plus x. Yeah, it's not, yes. Yeah, it's not a function of x, yeah. Actually, there are different ways to answer this question. I mean, if you want to solve for y, I mean, what you can do here, there are different ways to answer this question, because you can also, you can complete the square. You can add +1 both sides, and then you're going to have Um, um, I see there's a question. Glenn, can you factor? Yes, I can factor. I can factor out y. Yes, sure. That's another option. So here to answer this question here, there are different ways to do it actually. So as I said, first way is to you can complete the try to complete the square. You add +1. So then that will be actually y minus 1 square, and then you can get rid of the square, etc. But I think the easiest way would be to say, you can also try to solve for y. This is a quadratic equation, right? And if you solve the quadratic equation, you're going to end up with two possible solutions. So that's two possible outputs. Or you can just pick. You can also pick like let's say a random value of x, and the simplest value of x you can pick is, let's say, -2, because then the right side, this right side here would be 0. So if you pick x, let's say x equals to -2, right? Then we're gonna have, so if my input x is -2, then we're gonna have y squared minus 2y equals to 2 plus, of course, -2, and that will be 0. So we have to solve, we have to solve y squared minus 2y equal to 0. Then you can use the quadratic formula, or you can just factor y as a common factor. You see there's an y here, there's an y here, so I can, pull out the y. So let's pull out y. So we're gonna have y times y, that will be y squared, and then this minus, so here's my minus, and then there's 2, so here's my -2 equals to 0, right? And then you can just say, well, this is a product of two numbers equal to 0. So a product is 0 if one of the numbers or one of the terms is 0. So either y is 0, or so either this y here is 0, or this y minus 2 is 0. Okay, so guys, whenever you have a product multiplication, right, a product of two numbers equal to 0, then one of the numbers must be 0. So either y is 0 or this y minus 2 is 0. Okay, so in other words, either y is 0 or y is equal to +2. But anyway, my point here is that, so what I'm saying here is that if my input x is, this is my input, right? If my input x is -2, then I get actually two possible outputs. I get 0 and +2. So I get this 0 here and +2. So this is two possible outputs for x equals to -2, right? So if you have two possible outputs, then of course then f is not a function, y is not a function of x. So then y is not a function of x. Right? Yes. Yeah. You can plug in some values. Yeah, you can do that too. Yes. Actually, so what I'm saying here, I pick x equals to -2, but you can pick another value of x, and you can still, you can use the quadratic formula to solve for y. Okay, you can always use quadratic formula to solve for y anyway.
Professor,
And yes.
about it. So if we can plug in any other numbers instead of
-2.
No, instead of x to y to solve for y, it could be 0 or any number, right? But anyways, we're gonna get two different solutions.
Solutions, yes, because yeah, because
or what would be possible in that case?
Excuse me.
So we always have to find for one of the solutions equal to 0. or we can.
Yeah, that would be the easiest. Yeah, that would be like the easiest thing to do. Just to, move the y's to the left side, and the right side, you need to make the right side equal to 0. So here, that's why I picked x equal to -2. So then my right side would be 0. But I mean, instead of -2, you can also pick a different number. I mean, your right side doesn't have to be 0. If you, let's say your right side is 4 or 5 or a different number, you're gonna have a quadratic equation, right? And if you have a quadratic equation, it means you can use a quadratic formula, and then you're gonna always end up with, two. You're gonna end up with 2 possible outputs. Sure. So this is when you have, have an equation. Now for in D you have a graph. So when you have a graph and you want to determine whether y is a function of x, it's kind of a different story. So this is for D. So in D we have a graph. So the graph looks like so. So here's the graph. Yes, absolutely, it is. So for the graph, we use the vertical line test. Absolutely, yes, yes. So, yeah. So for the graphs, okay, so you have to use vertical line test. So what does it say? A vertical line test. So if you have a vertical line which intersect the graph at more than one point, then your graph is not a function. Okay, so if a vertical line intersect the graph at more than one point, you don't have to write down the vertical line test in the test. Okay, you need to use the vertical line test, but you don't have to write down what's the vertical line test. All right. So at more than one point, then the graph is not a function. It's not a function. Now, so for this particular graph, of course, if you use vertical lines, you use this one here, intersect the graph at 1 point, which is fine. Here, same 1 point. Here, it's 1 point, which is fine. Here, no point, and that's fine too. Okay. Again, the vertical line test the graph at the vertical line intersect the graph at more than 1 point. So it could be 1 point or no point. So it doesn't intersect the graph, that's fine. Here, same, it doesn't intersect the graph, right? This empty dot means that the point is excluded. So actually, this vertical line doesn't intersect the graph, which is fine. Here, same, intersect at 1 point, 1 point. So it's your vertical lines, they're gonna either intersect the graph at 1 point or no point. So in both cases, it's fine. So this graph is a function, right? So then the answer here, so the graph is a function. Okay. Any questions, guys?
Yes.
No? Oh yeah, please.
Could you do that again? The intersection, you said if it doesn't
Yeah.
intersect.
Yes. So yeah. So what I was saying, if you have a vertical line which intersect the graph at more than 1 point. So if you have a vertical line which intersect the graph at let's say 2 points or 3 points, right? More than 1 point, then the graph is not a function. But here, so if your vertical lines intersect the graph at 1 point or 0 point, then yes, then the graph would be a function.
Okay.
Okay, so you see here, I intersect 1 point here, and here there's no intersection, but that's fine. So 1 point or 0 point, it's fine. So it will be a graph. But if you have one vertical line which intersect the graph at more than one point, then your graph is not a
Okay.
function. Okay.
Okay.
Mhm. Sure. Is there any other question, guys? Okay, so then let's move to the problem number 2, unless there is any specific request. Okay, then let's move to the problem number 2 then. So problem number 2, again, you're asking problem number 6. Yeah, we can do that too, sure. Yeah, that's actually good. Yeah, that's a good idea actually to do the problem number 6, because this is section 2.2. All right, so problem number 6. Yeah, let's do that. So you have this f of x minus x squared plus 4x minus 2. Okay, so this is, of course, this is a quadratic function because, the highest power of x is 2. So this is a quadratic function, right? And so if you have a quadratic function, then the graph of a quadratic function is a parabola, right? Now, in A, you have to determine the vertex of the parabola. The graph of f of x. So what I'm saying is that the graph of f of x is a parabola, of course. Is a parabola. So in A, I have to find the vertex of the parabola. So A. So the vertex. So for the vertex, guys, we have a formula, right? Which is the following. So the vertex should be minus b over 2a. The x coordinate is minus b over 2a. And the y coordinate is f of minus b over 2a. So, this is a quadratic function. So it's of the form a x squared, of course, plus bx plus c, right? So then, of course, then a would be -1, b would be the +4, and your c would be the -2. So then your vertex, so the x coordinate, a vertex is a point, right? And the point, you have an x coordinate and a y coordinate. So the x coordinate of the vertex is this minus b over 2a. So it's minus b is 4. So it's -4 over 2 times a. A is -1. Right? So that's -4 over -2. Negative over negative is positive. And 4 over 2 is +2. So this is +2. Right? That's your x coordinate. Now, the y coordinate of the vertex. So for the y coordinate, all you have to do is to plug in this 2 in the function f of x. So you have to compute f of minus b over 2a, which is f of 2. So you have to plug 2 in the function f. So that would be minus x squared, so minus 2 squared, plus 4 times x, so 4 times 2, minus 2. All right, so then f of 2 would be negative 2 squared, that's 4, -4, plus 4 times 2, 8, minus 2. So -4 plus 8, +4, plus +4 minus 2, it's +2. So your y coordinate is also +2. So then the answer here, your vertex is, the x coordinate is +2 and the y coordinate is +2. Okay, this is a fine answer here. Here it's a coincidence that the x coordinate is the same as the y coordinate. Both are equal to +2, but it's just a coincidence here, all right? In general, they are different. The x and the y, in general, they should be different. Any question about the vertex? So in the test, guys, if you have to find the vertex, you have to use this formula here, right here. Okay, this is this minus b over 2a, and then you plug your minus b over 2a in the function f.
Professor,
Yes.
so -2 squared is it 4?
Well, I mean, Pamdam's rule, right?
Yeah.
You think of the negative as a subtraction. This is like subtraction.
Oh,
And the square, it's a power. So what you do is the power first, the 2 square first, that's 4, power first, and then the exponent first, and then the subtraction. So it's 4, and then there's a subtraction. So that's -4.
okay.
Mm-hmm. Any other question, guys? All right, so that's for the vertex. Now, next in B,
Professor,
yes.
you just talk about the 2 square, right? So, but we should multiply the sign as well. Like negative
Yeah,
times
of course.
negative is gonna be positive.
Well, we do have only one minus.
Oh, that's why because it's not in parentheses, or
Here, there's only this minus here. There's no, it's f of 2, right? It's not f of -2, it's f of 2. So it's this 2 square, and then there's only one minus. Why do you think there are two minus signs?
because it's a square, right? Because we have to multiply the number by the number of the power.
No, well, yeah, okay. So yeah, this is a good point. Okay, so the thing, okay, so it's, so what you're talking about is -2 square. If you have -2 square like this is, you know, in PEMDAS rule, parenthesis first, and then exponent, right? So it's parenthesis first, so I have my -2 first, and then I'm gonna do the exponent. So it's -2 times -2. But here I have minus, and then there is this 2 square. So the square, it's not, you apply the square not to the negative, you apply the square only to the +2. You see what I'm saying? So it's like there's this minus here, but then the parentheses, I mean, you apply this, the exponent to +2. You don't apply it to the negative. You only apply it to the +2. So we have 2 times 2, you do the exponent, okay, and then there is a minus. So it's a -4. So the first one here, of course, is +4. But the thing is, you have your x square, right? This minus x square. So the square, it's only applied to the x. It's not applied to the minus. So you do the square of x. You see what I'm saying? It's not the square of -x. It's not -x squared. That's not, it's not -x parenthesis square. It's x square, parenthesis, there's a square, and then there's a minus outside.
All right, got it.
No, I mean, this is really important because I know this is a common mistake, actually. But it's, yeah, yeah, just be careful, this PEMDAS rule. I mean, sometimes it's not obvious, yes. In B, there's the x-intercept and the y-intercept. Oops. X-intercept. So x-intercept, guys, that's the intersection of the x-axis with the graph of f. This is intersection of the graph with the x-axis. And so what we have to do is we have to solve f of x equal to 0. Okay, so again, this is intersection. Just to remind you, you don't have to write definition in the test, right? So if you have to find the x-intercept, just go ahead with solving f of x equal to 0. You don't have to write the definition of x-intercept, all right? So this is just to remind you the definition. So intersection of the graph with the x-axis. Okay, so all you have to do is to solve this f of x equal to 0. So it's this minus x squared plus 4x minus 2. Of course, we can use the quadratic formula. So it's minus b, so it's minus 4 plus or minus square root of b squared. That's 4 squared minus 4 times a. Don't forget times c, which is -2. Over 2 times a, which is -1, of course. Anyway, so your x is, so your x would be -4 plus or minus square root of, so 4 squared plus 16. There is this minus, that will be plus. So it's actually -8. So 16 minus 8 is going to be 8. So this is the square root of 8 over -2. 2 times -1, right? Actually, we can simplify this, right? This is, square root of 8. This is a remark here. I mean, 8 is 2 times 4, right? Then square root of 8, it's square root of 2 times 4. So that's actually square root of 2 times square root of 4. So if you have a multiplication, I mean, if you have a product under the square root, then yes, you can split, So the square root of 2 times 4, that will be square root of 2 times square root of 4. So if you have a multiplication or product, then yeah, you can split the expression under the square root, right? So that's square root of 2 times square root of 4. Square root of 4, of course, is 2, right? 2 times 2 is 4. So square root of 4 is 2. This is 2 here. And you have this square root of 2. So it's 2 times square root of 2, right? So what I'm saying, guys, is that this x, which is -4 plus or minus 2 square root of 2 over -2, right? So I can divide by 2, 4 over 2. Just be careful here. So, -4 over -2. So that would be positive. So that would be +2. There is this plus or minus over minus. So it's plus or minus again. There's a plus or minus. And then, there's 2, 2. So it cancel out. So it's the square root of 2. So it's 2 plus or minus square root of 2. Right? Yes. Yes, Kwame. So it's, yeah. So the answer here, we have 2 x-intercepts. So answer, so x-intercepts are, so first solution is 2 plus square root of 2, 0. Your answer should be in points notation, right? Your y is always 0 on the x-intercept, always 0. And of course, second solution is 2 minus square root of 2, right? And 0. And of course, this is always 0. The y is always 0. Okay, so that's the x-intercepts. Now the y-intercept. So the y-intercept. So just to remind you, definition of the y-intercept, it should be, the y-intercept should be the intersection of your graph with the y-axis. Intersection with the y-axis. Intersection of the graph, of course, with the y-axis. And for the y-intercept, all you have to do, yes, well, Lenin, the x is going to be 0 in the y-intercept. So yeah, so you have to plug 0 in the function f. So you have to evaluate f of 0. Always evaluate f of 0. Okay, so that's like -0 squared plus 4 times 0 minus 2. So it's actually -2. Yeah, so be careful also with the sign. So it's -2. So then the answer, the y-intercept is, yes, Lenin, it's 0, -2. So it's 0, -2. Okay, so your x is always 0. This always 0. X always 0. All right. Okay, so that's for the y-intercept. So x-intercept, always solve f of x equal to 0. Y-intercept, always just evaluate f of 0. All right. Now, next, the C. Again, guys, please feel free to interrupt me and ask questions if you have any question, right? So C, the axis of symmetry. Axis of symmetry, you know, for the parabola, it's actually a vertical line. This axis of symmetry, it's a vertical line, right? And it passes through the vertex. So it's a vertical line passing through the vertex. Okay, that's like the definition of the axis of symmetry through the vertex. So actually it has the same equation as the x coordinate of the vertex. So the equation is x equals to, so the equation is x equals to minus b over 2a, all right? It's the same as the x coordinate of the vertex. And it's minus 4 over 2 times, and of course, -1. So that's for +2. Okay, so the answer, the axis of symmetry is x equals to 2. All right, it's the same as the, again, x coordinate of the vertex. Now the D, whether f has a maximum or minimum and its coordinate. So let me just remind you guys. So if your A is positive, so let me just remind you here. So for D, so we have two cases, right? So if A is positive, then if your A is positive, then your parabola opens up, right? And then the vertex is going to be a global minimum, right? The vertex is going to be a global minimum. Okay, now if your A is negative, right, so then the parabola opens down. This is your vertex, and so your vertex, of course, is going to be a maximum. All right, so here in this example, I mean, this problem, your A is -1, right? So your A is -1. Of course, that's negative, is negative. So your parabola is going to open down, right? And so f of x has a global maximum at, well, at the vertex. Right, the vertex, which is of course +2. Right. So yes, so yeah, so that's your maximum. So it's gonna be the vertex. All right, so we answered the A, B, C, D. Now we're gonna use the A, B, C, D to graph or to sketch the graph of f, right? So now last question is to graph f of x. Okay, here, so now I'm gonna graph f of x. Well, to graph f of x, you have to plot the vertex, the x and y intercepts. All right, so so here's my so I guess I'm gonna need +2. So this is 1, 2. This is 1, 2. And then I'm gonna need a y-intercept is 0, -2. So where's my -2? This is 1, 3, and 4. All right. So anyway, so first thing is to plot the vertex, which is, you know, +2, +2, right? So here's my vertex. So this is +2. This is +2 here. So I'm gonna have my vertex. Right, so this is my vertex. Now, next, x-intercepts, right? X-intercept, so we said it's 2 plus square root of 2, 0, and 2 minus square root of 0. I mean, square root of 2 is, I mean, you can use a calculator. to approximate our square root of 2. So our square root of 2 should be like 1.7. So this is like 2 plus 1.7. It should be 3.7. So it's a number between 3 and 4, 0. So here's my 3.7 or 3 point wherever. It's a point between 3 and 4. 2 minus square root of 2. Again, square root of 2 is approximately 1.7. So it's 2.2 minus 1.7 should be like 0.3 or something. So it's a number between 0 and 1. All right. So here I have my x-intercept. Let me probably say this is my x-intercept. This is also my x-intercept. Right, and then next point is the y-intercept. It's 0, -2. 0, -2. So here's my y-intercept. All right, it's 0, -2. Now I have to draw the axis of symmetry. Axis of symmetry is just the vertical line passing through the vertex. So here's my vertical line passing through the vertex. This is my axis of symmetry. Anyway, now all I have to do is to connect the points. Remember, guys, my a is -1, right? My a is -1, so the parabola opens down. So, which means I'm supposed to start from the vertex, and I'm gonna go all the way down here. All right, and all the way down here from the left side here. All right. So that's my f of x. Well, to be honest, here should be, because we have axis of symmetry, so this point here should go like here. Should be like this. Anyway, yeah, so that's my f of x. Any question, guys? So remember, your parabola opens down, so you start from the vertex and you go all the way down. Just join the points, okay? Okay, perfect. Then no question. So yeah, Glenn, so that's for problem number 6. I don't know if you have any other question about this section. Otherwise, I guess I can come back to the problem number 2, unless there is a specific or a special request. Okay, so then let's do number 2 then, the domain. I think this is a really important question for the domain. Oh yeah, Daniela, you're saying problem number 8. Yeah, sure, problem number 8. Where is it? Okay, yeah, that's actually a very good problem. That's a very important problem. Problem number 8. Okay, so in the problem number 8, we have to find the inverse function. So yes, we'll do problem number 2 after 8, Elisa, no problem, sure. We still have time, yes. So problem 8. So the inverse function. So okay, so what I'm gonna do, I'm gonna write down, I'm gonna make a table. On the left, I have my function f of x, which is x minus 3 over 4 plus 5x. All right, and on the right side, I'm gonna write down the steps. So first thing to do is to just replace f of x by y. So here's so f of x becomes y. This is x minus 3 over 4 plus 5x, right? And then so then next step would be to interchange x and y. So number 2, interchange x and y. All right, so then y becomes x equals 2. So x here becomes y. So this is y here, And there's a line here in the bottom. So that's y minus 3 in the top, and then 4 plus 5y in the bottom, right? Now, last step, which is the main step, we have to solve for y, right? So how do we solve for y? Well, again, this is when you have a fraction, guys. So this is, this is x. You have a fraction in the right side, 4 plus 5y. All right. So the thing is, you have y in the numerator and also in the denominator, right? So the best thing to do, I think, or the easiest thing to do is first. So because you have a fraction on the right side, I'm gonna make the left side look like a fraction. So I'm gonna divide x here by 1. All right. So now both sides are fractions. And now you can cross multiply. So you cross multiply. So then your x, you're gonna have x times 4 plus 5y equals to 1 times y minus 3. Okay. So whenever you have two equal fractions, you can always, cross multiply, and that will be equal. So then here I can distribute, of course, x times 4, that's 4x. X times 5 times y, so that's 5xy. And on the right side is just 1 minus 3, of course, times 1. Now, the idea, how do you solve such an equation, right? You want to solve for y. You have y on the left side and y on the right side. So first thing to do is to move all the y's on the same side, okay? And then you move everything else to the other side. So so what I'm saying is, like, here I have y, so I'm gonna keep this y here, the 5xy on the left side. I have this y here on the right side. So what I'm gonna do, I'm gonna move it to the left side, right? So here, subtract y, subtract y. So that would be 4x plus 5xy minus y. Then this is y minus y, cancel out, so this is negative 3. Okay, now I have all the y's on the same side. Okay, and then I have this 4x. Okay, there is no y here in 4x, right? So I'm gonna move it to the other side. So why I'm doing this, guys? Because so once you move all the y's on the same side and move everything else to the other side, you can factor out y. So then y would be a common factor here, right? So that's why I have to move this 4x to the other side. So then here and here, in both terms, I'm gonna have y, so I can pull out y, right? So first, let's subtract 4x. So it's 5xy minus y equals to negative 3 minus 4x. So you see now I can pull out y here and here. So let's factor. So then I'm gonna have y times, then there's this 5x, so here's my 5x. There's this minus here, so here's my minus. And this y here, if you pull out this y, you are left with 1, because this is like y times 1. So you are left with 1. So this is actually minus 1 equals to minus 3 minus 4x, or negative 3 minus 4x. All right, so you see now I can divide both sides by 5x minus 1. This is 5x by minus 1. So then I can get y. So then my y would be negative 3 minus 4x over 5x minus 1. And so that will be a fine answer. That's your F inverse. So my F inverse, so after the negative 1. So this notation here, after the negative 1, that's the inverse function, okay? F inverse. So inverse function, it's negative 3 minus 4x over 5x minus 1.
Professor, I have two questions.
Yes, yeah.
My first question is, so when we find the inverse of problems, are we always able to cross multiply, or are there going to be some times where it's just we can't do that?
Yeah, I mean, the thing is, whenever the idea is whenever you have fractions,
Yeah.
like here, you see, because I have this right side here, I do have a fraction, right? So when you have a fraction, I think the easiest thing to do is to cross multiply. You can cross multiply, and and then you can solve your equation, right? But if you don't have a fraction, like I don't, if you don't have a fraction on this side here, on this right side, okay, then you don't have to cross multiply. It's not, you don't need to cross multiply. All right. So what I'm saying is, if you have an equation and one of the sides of the equation is a fraction, right? Then you can cross multiply. You can always cross multiply, and then you can solve your equation.
Thank you, Professor. And for my
Mhm.
second question, I was gonna
Yeah.
ask. So for like today's notes, is it gonna be like released tonight or tomorrow?
I also don't know. So I'm gonna upload the recording today.
Okay. Thank you, Professor.
Yeah, sure.
Sir,
Yes.
following up on Josh's question, can there be
Yes.
questions you can't actually cross multiply?
Which here?
Yeah, like they'll give a question that you can't cross multiply.
Yeah. So yeah, I mean, what I'm saying is, here I have to cross multiply because one of the sides is a fraction. If you have an equation, you have an equation and there's no fraction, okay, then you don't have to cross multiply. So what I'm saying, in the test, yeah, you should expect, you could you could possibly end up with a fraction and then you have to cross multiply, or you can have something where or an equation where there's no fraction, so then you don't need to cross multiply. Yeah, you should expect, of course, anything in the test. I mean, in theory, of course, but um, yeah. So it depends on your equation. If you have a fraction in your equation, then yes, you have to cross multiply. I mean, one of the options is to cross multiply. But if you don't have a fraction, don't cross multiply.
Okay, okay, okay.
Okay. But in the test, yeah, you should expect either. I mean, either fraction or something else. Yeah, sure. Um, yeah. So, is there any other question, guys? All right. So then let's probably come back to the problem number 2. Um, and again, guys, I'm always open to any specific request. Um, so this is problem number 2 from the review sheet, of course. All right. So for problem number 2, you have to find the domain. So for F, so for 1, for A, yes, again, we can do problem 3 after that. Yeah, sure. Yeah, so for F of X, so we have X minus 2 over X minus 5. Okay. So guys, I mean, in general, when you want to find the domain, I mean, there are 2 cases. If you have a fraction, then all you have to do is to solve the denominator equal to 0. And if you have a square root, right, then and you have something under the square root, then of course you have to solve the what's under the square root larger or equal to 0. So here, whatever you have under the square root, larger or equal to 0. Right. Of course, if you have something outside the square root, then you don't really worry about it, right? So anyway, so it's this f of x, of course, is obviously a fraction, right? So we have to solve this x minus 5 equal to 0. So and then x is 5. So you have, this is to be excluded, right? So 5 is excluded from the domain of f, right? So the domain of f is going to be any real number except 5. So the answer, of course, D subscript F, it's negative infinity, 5 excluded, union with 5 excluded to the positive infinity. Okay, so your domain will be the whole number line except the 5. So that's a fraction. Now for B, of course, it's a different story. For B, it's not a fraction, it's a square root. So that's your g of x. It's square root of x plus 3. So what do we have under the square root? So under the square root, we have x plus 3. So we have to solve this So we have to solve this x plus 3 larger or equal to 0. Right? So then, of course, your x subtract 3. So your x is larger than negative 3. So your answer, domain of g, d subscript g, you start from, so any number larger than negative 3. So it starts at negative 3. Negative 3 is included because of this line here. It can be, x can be equal to negative 3. So it's negative 3, of course, and goes all the way to positive infinity. Now, this is a common mistake. So I saw this mistake in homeworks and etc. But so for f plus g, so a domain of f plus g. So you don't have to compute the f plus g. Don't compute f plus g. You don't have to compute this f plus g. Okay, because we have a theorem which says that the domain of f plus g or f minus g or f times g is the common domain. So all you have to do is the common domain to f and g. Okay, so we have to find the common domain. We don't have to compute the f plus g. So we have to find the common domain. So what's this common domain? Well, here's my number line. I guess I'm gonna need 5. I guess I'm gonna need also negative 3. This is negative infinity. This is positive infinity. So first, of course, in the test, guys, you don't have to draw the number line. I mean, your final answer should be in the interval notation, of course. But I mean, I think the number line would help you to find the common domain. So first, you start with the domain of f. So domain of f is any number except 5. So here's my domain of f, which is the red d subscript f, domain of f. It's the red domain or red interval. Now, domain of g, well, it starts at negative 3 included, and goes all the way to positive infinity. Okay, so the green domain is the domain of g. Now, what will be the common domain to f and g? What will be the domain which is, or the interval, which is green and red at the same time? So it starts at negative 3. Negative 3 is included because negative 3 belongs to the domain of f and also to the domain of g. Then we have to exclude 5 because 5 is not in the domain of f, so it's not common to f and g. And then, of course, all the way to positive infinity. So your answer, domain of f plus g, is the common domain. So it's negative 3 included to 5 excluded. You exclude 5 union with the 5 positive infinity. Okay, so this is our common domain. So you see, guys, I didn't compute f plus g. You don't have to compute f plus g. Just find this intersection or this common domain, right? And actually, this answer is also valid for, I mean, this is also, oops. So this is also valid for f minus g, okay, or f times g. Okay, that will be the same domain. All right, now for f over g. So f over g, there's one more thing to do. So so for d, if you want to find, so this is d, you want to find the domain of f over g, then So what we have to do, guys, because f over g is a fraction, right? This is a fraction. Remember, when you have a fraction, you have to solve the bottom equal to 0, and you have to exclude the values where the denominator is 0. So what we do is we have to exclude the values where the bottom is 0 from the common domain. Exclude the bottom equal to 0 from the common or intersection domain. Okay, here, of course, f over g, the denominator will be g, right? Like for the next problem, g over f, the denominator will be f. So then you have to solve f equal to 0. But here in D, for f over g, we have to solve g equals to 0. So here we have to solve g of x equal to 0, because g is the denominator. So g equals to 0, so that's square root of x plus c equal to 0. So then, you can apply a square root both sides. Sorry, you can apply square both sides. So then this is x plus c equal to 0. And so your x, of course, is -3. So this is to be excluded from the common domain, right? So again, here's my common domain. This is my common domain, right? This is my common domain, and I have to exclude now this -3. Okay, so now, so then the answer, so the domain of f over g would be -3 excluded, right? I have to exclude -3, so it's parentheses -3, 5, union 5, positive infinity. All right. Any question, guys? Now, for the domain of g over f, domain of g over f. Now, again, this is a fraction, but now the denominator would be f. So we have to solve. Now we have to solve f of x equal to 0. Okay, because your f is the denominator. Okay, and so f is, of course, x minus 2 over x minus 5 is equal to 0. So we have a fraction equal to 0, and whenever a fraction is equal to 0, it means that the numerator, the top, is 0, right? Because 0 over any non-zero number is 0. So fraction is 0. So what I'm saying is, if you have a fraction equal to 0, then the top will be 0. Okay, so here we have to solve the top, which is x minus 2 equal to 0. We don't really care about this, the denominator, the x minus 5. So then x is equal, of course, to 2. So this is to be excluded from the common domain, to be excluded from the common domain. All right. Remember, here's my common domain. This -3 included, 5 to 5 positive infinity. That's my common domain. And now I have to exclude 2, right? So then domain of, so the answer here, so the answer is, so domain of g over f would be -3 included, because it's in our common domain. Then 2 must be excluded, union 2 excluded, 5 again excluded, union with 5, and then positive infinity. All right. So I had to exclude the 2 from the common domain. Again, I didn't compute f over g or g over f or anything, right? I just find the common domain, and then in case of a fraction, g over f or f over g, you have to, solve the denominator equal to 0 too. Now, F, you have F composed with G. So this is a F composed with G is different. So this is a different situation because we don't really use the common domain to F and G. It's not about the common domain. So for F, I mean, problem F, so we have to find domain of F composed with G. Again, this circle, this is not multiplication, this is composition. Okay, it's not multiplication, right? Now, how do you find the domain of F composed with G? We don't use the common domain here. So first step, when you find, if you want to find the domain of F composed with G, so step one, you have to find the domain of step one, find the domain of the second function. Find domain of the second function, which is g of x. The second, this is my first function, and then here's my second function. So of the second function, which is g of x. All right. Of course, I know the domain of g of x. We already solved the domain of g of x, right? So, which is actually, we said it's negative 3 included to positive infinity, right? And then next, what we have to do is we have to compute. So here we have to compute F composed with G. So here we have to compute, find F composed with G, all right? So, and so let's compute F composed with G. So this is F composed with G of X. This is, by definition, it's F of G of X, right? But then, F of X is, it's X minus 2 over X minus 5, right? So there's an X in the top here and X in the bottom. So we have to replace or substitute both X's by G of X, right? We have to substitute the X in the top by G of X and the X in the bottom by the G of X. So that will be G of X minus 2 over G of X minus 5. Okay, so then your F of G of X. So G of X is square root of X plus 3. So square root of X plus 3 here, minus 2 over square root of X plus 3 plus minus 5, sorry, minus 5. Okay. Now, you have to define domain of this F of G of X. So what will be the domain of F of G of X? Domain. So what will be domain here? You have, of course, it's a fraction, all right? This is a fraction. So fraction. So we said we have to solve the bottom equal to 0 if you have a fraction, right? So here's a fraction here. So the bottom would be, or denominator would be the square root of x, square root of x plus 3 minus 5 equal to 0. So let's solve for x, so plus 5 plus 5. So the square root of x plus 3 equals to 5. Get rid of the square root, so we're gonna apply square both sides. Here's a square, here's a square. And then, so there'll be x plus, sorry. So there'll be x plus 3 here, equals to 25, subtract 3. So then your x is 22. Okay, so this is to be, of course, excluded. All right, so this is our step number 2. So so we have this in the last step. I can find find the answer. You take the intersection. So the step 3. So you intersect, we take the intersection, sorry, of the domain in step 1 and 2. Step 1 and 2. So step 1, that's the domain of G, right? That's this -3 positive infinity. So domain, this is step 1. We said domain of G, -3 positive infinity. All right. And in the step 2, we said we have to exclude the 22. All right. So then, from my number line, this is -3. Here's 22. So I have to take -3 and exclude 22. So it goes all the way to positive infinity. So the answer here would be, so domain of F composed with G will be -3 included, 22 excluded, union 22 positive infinity. All right. Any question, guys? So I mean, domain of F composed with G is a little bit different from. I mean, it's not the common domain of F and G. It's a little bit different. But yes, in F composed with G, you have to find this F of G of X. Okay. Any question, guys? Okay. So otherwise, Glenn, you suggested the problem number 3, right? So let's do number 3 then. Okay. So let's probably move to the next page here. And so here, problem 3. Again, this is from the review sheet. All right. So, okay, yeah, this is the same. Same graph from homework number 2 or 3 or something. Anyway, so let me just graph again this f of x for you. So here's. So I'm gonna probably need -1, -4, -4 here, -2, -1, +1, 2, 3, and I'm gonna need 4. And in the top, I'm gonna need 1, 2, 3, and 4. All right, so then my graph would be, so here, -4, -2, 4. Here's -2, 4. And then we have 0, 1, 0, 1, then 3, 2 here, and then this 4, 0 here. Okay, so here is the graph of f of x. Right, this is f of x. Okay. Yeah, I'm sorry, it's not nice. It's kind of a mess, but anyway, oops. Okay, so anyway, so let's say this is my f of x. First question, guys, you have to find the range of f, okay? So remember, let me just remind you, the range, that's the set of the outputs y, right? So for the range, guys, so how do you find the range? So we have to use, horizontal, you have to use horizontal lines. Okay, so you have to use the horizontal lines, and let's say this is, of course, here's negative infinity, here in the top this is positive infinity. So whenever your horizontal line intersect the graph, then the corresponding y belongs to the range of f. Okay, so if the horizontal line intersects the graph, then the corresponding y. So it's a range, right? So it's about the outputs y, right? This is about the outputs y. So then the corresponding y is in the range. Then another thing, you have to go from the bottom to the top. You start from the bottom and you go all the way to the top. So what I'm saying, guys, is that, so here, so if we start from the bottom, let me probably take here. So this thing here goes all the way down. So let's take vertical lines, right? Sorry, horizontal lines. So you start from the bottom at negative infinity, right? So here at negative infinity, remember, guys, the arrows mean that the graph doesn't stop. It continues. So here at negative infinity, you're gonna have actually intersection, right? So this point here, negative infinity, is you start from negative infinity, then you go up. So this line here, of course, you're gonna have intersection. So here you see I have to find my range on the y-axis. So I have to check, the corresponding y value. So these y values here, they are in the range. So I'm going from the bottom to the top. So of course here I'm still having intersection. Here's an intersection, all right? If you go up here, you still have intersection, right? So this is still in the range. This is still in the range. I arrive here. You have intersection, okay? So it's still in the range. You go up here. This is still have intersection, right? So this is still in the range, until you arrive at 4. So you see, guys, after 4, if of course here at 4, you're gonna have intersection at one point, exactly one point right here, okay, at this point here. But then if you take a horizontal line just after 4, like here, okay, so this is all right. Then after 4, of course, your horizontal line doesn't intersect the graph, right? So then it's not in the range. So your range goes from negative infinity to positive 4, where positive 4 is included because we do have an intersection here at this point here, right? So anyway, so then the answer here, the range would be, so you go from bottom to the top. So it starts at negative infinity. Negative infinity is always excluded anyway. So negative infinity to positive 4. Positive 4, of course, included because we do have intersection at positive 4. Right? So that's how we find the range. Is there any question, guys? Now, about the domain, instead of using horizontal lines, for the domain, we use vertical lines. It's the same idea. So for the domain, just to remind you, so for the domain, so we have to use vertical lines, and you go from the left to the right, right? And your domain is going to be on the x-axis, so you have to check the corresponding x values, right? Anyway, so that's
Can you
for
do an example of that?
Oh yeah, sure, of course. Okay. Okay, here's an example. Yeah, actually, I forgot to give an example on the survey sheet. Yeah, it's actually a very good question. So let's see here. So This is -1, +1, +2, -2, this is -4, let's say. All right, and probably here's -1, here's +2. So anyway, so here's, let's say this is my graph. Let's say it starts from, let's say from let's say from here, and say this is my f of x. Okay, and then let's say probably I have this. Okay, I'm gonna just probably have this. So here I'm gonna have -4, of course. This is -4. This is +4. This is +5, and this is +infinity. Okay, so let's say this is my f of x. This is point here. Okay, so this is my f of x. Now, as I said, so you go, and of course, here's -infinity here. Anyway, so I'm gonna use now vertical lines, right? You start from the left. I said you start from the left. So here's my left. You start here from the left at -infinity, and of course, here at -infinity, there's no intersection, right? So you continue. There's no intersection. Well, then you arrive at -4, and you're gonna have your first intersection at -4. So here I'm gonna start my domain at -4, right? So of course here you're gonna have intersection at this point, for example. So I'm gonna have intersection, etc. I'm gonna go to 0 here. Of course, I have intersection here, here and here. So I can go until +2, but then here, just be careful, this +2, because I have this empty dot. So then this +2 is not included. But then, guys, between 2 and 3, if you take a horizontal line between 2 and 3, there will be no intersection, right? So the numbers between 2 and 3, they are not in the domain, right? But then you're gonna have, again, intersection +3. Here we do have an intersection at +3, so this is in the domain, and so we're gonna have intersection again until, so from 3 to 5. Okay, but then of course after 5 there will be no intersection, right? Here there will be no intersection, here there's no intersection. So you see, your domain would be like from -4 all the way to +2, and then like from 3 to 5. All right, so so then the answer, so this domain here would be, so -4 is included because you have this, they have this full dot. So -4 is included from -4 to +2, but then +2 is not, it's not included because you have this empty dot at +2, right? So this +2 is excluded, union, and then you're gonna have intersection again at 3, as we said. 3 is included because this is a full dot. So 3 included to +5. +5 is also included, right? Because it's a full dot at +5. So that will be my domain. So I'm using vertical lines. I go from the left to the right. Whenever I have intersection with the graph, then that will be in the x, corresponding x value would be in the domain. Sure. Any other question, guys? All right. So then in this question number 3, we have to find the x-intercepts and the y-intercepts. So keep in mind, x-intercepts are the intersection of the graph with the x-axis. So this is a B, I guess. Oops, this is B in problem number 3. So x-intercepts. So this is intersection of the graph with the x-axis. So of course, here's my function f. Intersection with the x-axis. We're gonna have intersection here and here, right? At -4 and +4. That's That's where my graph intersects the x-axis. So -4 and +4. So the answer here. So your answer, to get full credit, guys, your answer should be in points notation. So -4, y is always 0, and +4, y again is 0. All right. Now for the y-intercept, this intersection with the y-axis. Right. So then if you check the graph, intersection with the y-axis, well, then the intersection is going to be this point here. This, oops. So it's going to be this point here. This one, right? That's my intersection, the intersection of the graph with the y-axis. And that's actually the point 0, 1, right? Y is equal to 1 there. And x, of course, is 0. So y-intercept will be 0, 1. So the answer. So y-intercept is 0, 1. Next, local maximum, local minimum. So let me just remind you guys, for local minimum, local maximum, you know, whenever I have like a parabola, you know, if you have like a small parabola like this, then this point here would be local maximum. And if you have, you know, small parabola open up, then that would be a local minimum, right? So here, so where would be our local maximum? Well, we have this first point here, this one here, you see here, it looks like a small parabola here. So, and this is actually, this point here, this is like the highest point of the graph. So obviously it's gonna be actually a global maximum. So it's a global maximum at actually -2, right? So we have, this is our first local maximum, and it's actually a global one. Now, the other point would be this one here. I mean, this is not really, the graph is not very good here. But anyway, this is supposed to be like a parabola. So here at this point, we can also have a local maximum, which is at positive θ, right? So we have two local maximum at positive θ and at -2. Now, what about local minimum? Well, here you can see here we have like a, you know, small parabola open up. So this point here, the 0, 1, would be a local. This is a local minimum, right? So yes. So anyway, so what I'm saying is the local maximum at -2 and positive θ. So this is I think question C. So local. So local maximum at x equals to -2 and x equals to positive θ. And we do have a local minimum at 0, 1. So your x is 0. All right. Now, next, the E, f of -2. You know, if you you check your graph, x is -2. So here's x -2, right? So what would be f of -2? Well, the corresponding image or output of -2 would be this point, which corresponds to y equals to 4. So f of -2 would be 4, right? So f of -2 is 4. F of -2 is 4, right? Then next, you want to find f composed with f of 4. Okay, again, guys, this is not multiplication. This is a composition, right? So this is composition. So f of composed with f of 4. Then this is by definition, this is f of 4. Right? So first, you have to find this f of 4, which is between parentheses. So what's f of 4? F of 4 is, sorry. Sorry. So f of 4 is, where is it? Here. So this is x equal to 0. So f of 4 is actually 0. So what? So we have 0 between the inside the parentheses. So this is equal. So here's parentheses. So between parentheses is 0. So this is f of 0. And of course, guys, there's this f in here. There's another f outside. So now we have to evaluate f of 0. Okay. So what's f of 0? Well, if you check the graph, it's 1. Thank you, Leah. Yes. So f of 0 is 1. And so that's the final answer, right? Yeah, I mean, the same thing. I mean, same idea for f composed with f of a negative 2, f of composed with f of a negative 4. I mean, if you understand how it worked for this example, then the g and h is just the same kind of problem. All right, so because we have just 10 minutes, so I think probably it would be a good idea to move to another problem. Well, yeah, let's probably talk about this problem number 4, unless you want me to do a different problem. But yes, so let me just probably go over this problem number 4. And problem number 4, you have to sketch minus f of x plus 2. Okay, so let me just probably graph. This is 1, 2, 3, 4. This is negative 4, of course. Negative 2. This is 2. And this is 4. There's 1 and 2. And I'm going to need negative 2, I guess. So here's a point. There's a point here. Another one right here, and finally here. So this is my f of x. All right, this is my f of x. So you have to graph. So we have to graph minus f of x and then plus 2, right? So first, you have minus f of x. So minus f of x, I mean, you have, you need to check your transformations, guys, but minus f of x, that's the reflection about the x-axis, right? This is the reflection about x-axis. If you had f of minus x with a minus inside, f of minus x, that will be a reflection about the y-axis, right? So this is a reflection about the x-axis. And then after the reflection about the x-axis, we have the plus 2, which is outside the parentheses. So this is, if it's outside, then there will be a vertical shift. This is a vertical shift, plus 2 outside the parentheses. And we have to move or shift our graph up because of plus. So we have to shift up by 2 units, up by 2, right? So first, we're gonna start with the reflection about the x-axis. So let's, so I'm gonna start with the reflection about the x-axis. So like this point here lies on the x-axis. So its image about the x-axis, reflection about the x-axis is the same. This point here, its distance from the x-axis is 2. So we're gonna go 2 on the other side, up by 2 here, and that will be the reflection of the point above the x-axis. This one here lies on the x-axis, so it doesn't change. This one here, its distance from the x-axis is 2, so we're gonna go down by 2 here, down by 2, and then there's this point here lying on the x-axis, so its image is gonna be the same. So minus f of x is gonna be this blue graph here. That's my minus f of x. It's a reflection about the x-axis. And now next, and so that this should be your final answer. So next, you have to shift your graph up by 2, right? So like this point here is gonna go up by 2. This one here up by 2. So you shift your blue graph up by 2. So here's up by 2, up by 2, and this one here up by 2. All right, so first you do the reflection, and then next you shift the graph up by 2. So here's my minus f of x plus 2. So this is, so the green one, this is a final answer. That's my minus f of x plus 2. Right? The blue one is just minus f of x. It's just like the first step. And then the green one is the final answer. That's my minus f of, this is your final answer. All right, in the test, guys, you don't have to, I mean, you don't have to graph minus f of x if you don't want to, okay? But I guess it's would help if you graph minus f of x first, and then, of course, shift your graph up by 2. Any question, guys? Okay, so otherwise, if there's no questions, then we have 5 minutes. So I'm gonna go over number 5, the even, odd, or neither. Okay, so for number 5, so problem number 5, right? So you have to determine whether the function is even, odd, or neither. As I said, of course, you can use the definition of odd or even, but you can also just, check the powers of x. So like here, x, first f, you have x cubed minus x. This x here, it's actually power 1. All the powers are odd. So then your function f is odd. So all powers are odd. Then f is odd. Like for the next one, you have f of x, which is x fourth minus x squared plus 1. So this is 4, this is even, 2 is even, this is 1, but 1 here is actually x times 0. Okay, so x to the 0, it's 1. Okay, so here all the powers are even. Powers are even. Then f is even. And f is even. Okay, so in the test, guys, of course, you have to justify your answer. So you have to say, for example, all the powers are odd or even, then the function is odd or even, etc. Or of course, you can use the definition of odd and even, right? F of minus x equal to f of x, etc. Okay, but anyway, you have to justify your answer. If you just say odd or even, then you don't get full credit. Okay, you have to justify your answer. And last one, f of x equals to x plus 1. So this is x here, this is power 1. Again, this is 1 here, it's like times x to the 0. So we have 0 and 1. So 1 is odd, 0 is even. So this function is neither. Okay, so we have odd and even powers. So then f is neither. Right? Okay, is there any question, guys? I think we did most of the problems, probably, right? I guess, yeah, I think I did all the requests at least, yes. Okay, so I guess I'm gonna stop here, guys. Is there any question about the test? So again, I'm gonna upload the recording today, probably later in the
Professor,
evening.
I
Yes.
think someone had asked how many problems there were gonna be. Did you answer?
I think, yeah, if I remember correctly, it's gonna be 9 problems.
Got it.
Mhm. Any other question, guys? Yeah, anyway, if you have any question, you can always email me, right? Yeah, so let's stop here.
Are you
And
going
again,
to assign homework or no?
assign new homework.
Yeah.
No, not this week. No,
All right.
not this week. Yeah, no, this is just this week is just for the test. So what was I'm gonna say? Yeah, so again, on Wednesday I'm gonna post the test at 12 p.m. and you have until 2:15 p.m. to submit your answers, guys. Okay, Wednesday 12 p.m. on Blackboard. All right, so I'm gonna wish you good luck, and of course, stay safe and take care. See you guys. Thank you, everyone.
Thank you, Professor.
Professor,
Yes,
is it a one-time test?
one-time test. What do you mean one-time test?
As in, it's only one attempt, or you could redo it?
Oh no, it's one time, of course. There's no
Okay.
way. Yeah, if you get the wrong answer, then yes, it's yeah, it's just one time. Yeah, of course.
So we can upload to Blackboard or email to you as well.
Yeah, sure. It's up to you. You can
All right.
upload your answers on Blackboard, or you can email me your answers. It's up to you.
Thank you.
Okay.
Oh, thank you, Mamadou. I got you. Thank you. Thank you, Alexander.
Professor,
Yes.
you received my homework 3.
And you are, sorry, I don't, who? Sorry?
Daniela Alvarez.
Oh, yeah, Daniela. Yeah, I got your homework number 3. Yeah, thank you. Yeah. Sorry,
Okay.
I didn't. Yeah, I got your homework number 3. Yeah, thank you.
Okay, thanks.
Thank you. All right. I guess, is there no more questions? All right. So, see you guys next time, and I wish you good luck on the test. Thank you, Mamadou. Thank you, everyone.